Welcome to the deep dive. Today, we're doing something a little different. We're zooming way in on a single industrial component.
A tiny one at that.
Exactly. It's the NTI E-BEEP1-P200 rugged miniature piezo alarm. And our mission today is to figure out the massive thinking behind this tiny piece of hardware. On the surface, it's pretty simple. It's a general-purpose siren, makes a continuous tone, and it's loud, like 103 decibels loud.
And that's really the starting point. I think it's the perfect example of an unsung hero in, distributed infrastructure.
An unsung hero. How so?
Well, it provides these critical audible alerts when sensors detect trouble. Could be a temperature spike, could be an intruder, but every single spec points to this core idea, resilience in complete physical isolation.
Okay, let's start there. The volume, you said 103 decibels at 2 feet.
Right.
To give you some perspective, that's like standing next to a jackhammer.
Yeah.
So my question is, why a tiny piezo siren for that? Why not a bigger horn system?
That's where the efficiency comes in. I mean, sure, horn is loud, but this thing runs cleanly on low voltage DC power.
We're talking 12 volts, right?
Exactly, 12 volts DC, though it's got a range from 5 to 15. It's purpose-built to plug right into the NTI monitoring systems. It's a specialized tool for tight integration, not just a standalone speaker.
So it's about getting maximum noise with minimal power and complexity.
You got it.
Okay, so given that, where are you putting this in?
It has to scream across a huge space, but it's also running on low voltage. And it's the size of a golf ball. The durability specs seem almost like overkill.
They do, until you understand where it's meant to go. The miniature size is a feature. It lets you mount it anywhere. But yeah, the other features tell you its intended home is brutal.
How so?
It's fully epoxy encapsulated. Polarity protected too, so a simple wiring mistake won't kill it. It's built from the ground up to resist water, humidity, vibration, all of it.
Because if the alarm fails, the whole system might as well have failed.
Precisely. And the ratings back this up. It's IP68 rated.
That
means it's completely dust tight and can handle being continuously submerged in water indefinitely.
Wow. And then there's the ASTM B117 rating. That's a salt fog test. It proves it can resist rust and corrosion in, say, a marine environment or a chemical plant. You just don't put that kind of hardening on a device for a clean server room.
No, you put it in a humid tunnel or maybe an outdoor facility, somewhere remote.
Exact.
This is incredible resilience for something so small.
Yeah.
So let's talk about the final piece, the connection. It's a simple 2-wire setup, but the maximum cable length is 1,000 feet.
1,000 feet, over 300 meters.
What does that kind of reach imply? I mean, why would you ever need that?
This is what ties it all together. A 1,000-foot cable run means this alarm isn't just in the next room. It's designed to be in a completely separate building, a remote generator shack, a different wing of a campus, maybe a hazardous area that's physically walled off from the control room.
So the controller and the alarm are totally isolated from each other.
Electrically and physically, yeah. The whole system is designed to maintain that loud, clear signal over an enormous distance where failure just isn't an option.
So when you put it all together, this tiny alarm is actually a hardened communication node. It's built to bridge this huge physical gap between a problem and the people who need to know about it.
That's the perfect way to put it. It's the sound of system integrity, no matter how nasty the environment or how far away it is.
So the takeaway is?
It's the combination, right? The jackhammer volume, the IP68 immunity, and that 1,000-foot reach. That's what defines its value in modern infrastructure.
Which leaves a final thought for you to chew on. Considering that level of durability and that maximum cable length of 1,000 feet, what kind of complex industrial scenarios require you to place an alarm that far away from its central monitoring system? Think about the environments that demand both that protection and that incredible reach. What problems are they solving? That's a deep dive for you to consider.